Hi, my name is Teacher Steve, a teacher of physics and mathematics. And today we want to have a look at Ohm's law, a very important law in physics, and carries some good part of uh, electricity in practical and even in theory. So I want us to open our virtual lab, the lab exchange. We open that and see how this one is well illustrated here. So I'll go to the subject, then I go to physics, then I'll go to circuits where we have that, and wait my for some few seconds my page to load. Then you're able to see what happens there. So here we have the Ohm's law. I'll click that one and the page again to load and to see what comes in that page. Just to remind ourselves that Ohm's law help us to understand how does a potential difference across a conductor relate with the current. And the law itself states that the current flowing through a conductor is directly proportional to the potential difference across its end, provided temperature and other physical properties are kept constant. So let me see how that one works. So I'll open that to see what happens here. So here I have a formula. It's a mathematical formula uh, relating potential difference, which is voltage, which equals to current. Then you multiply by resistance. So I'll be varying the voltage, the variables here, the voltage and resistance. Then I observe what happens to this current. Does it increase or reduce? So here we have from these variables that I'm given here, if you take a voltage of 4.5 and a resistance of 500 ohm, and you substitute in this formula, it will give you 9.0 milliamperes, which is the same as 0.009 amperes, because 1 ampere is the same as 1,000 milliamperes. So I want to see how this one relate with each other. So I'll vary the voltage, then I observe what happens. So when I increase my voltage, I the more I have more number of dry cells, then the more I'm having a bigger voltage. So if I increase this one, the voltage here, then I'll see more dry cells increasing here. And I also want you to check the formula here. What happens? Uh, does these variables, the letters here, V, I, and R, when I'm varying the voltage and resistance, what happens to them? Then it's a good picture for us to observe and just to have a visual of this formula, a very important topic in physics. So here I have a conductor. So I have three dry cells here. Then you have a conductor here, which is represented here. And of course, it has some resistance within. So if you might be asking, where is 9 coming from? I think uh, if substitute these values to this formula, I've said it will get 9. That. So let me begin with voltage. If I increase voltage, look at what is happening in my, first of all here. If I increase, let me put the volume down. If I increase the voltage here, then my current is also increasing. If I reduce the voltage here, also my current is reducing. So we can say that voltage and current, they are directly proportional to each other. When one moves up, the other one moves up. When voltage moves down, also the current moves down, or we get a smaller value here. So that is how voltage and current relate with each other. So they are directly proportional. What happens when I take resistance? What happens when I increase resistance or I reduce the resistance of a conductor? So if I increase the resistance here, I want you to also observe the letter here R for resistance, and even what is happening here. What is happening here? I'm sure you can remember what is resistance. We define resistance as the opposition, to the rate of flow of charges. So this is a kind of, I am creating more opposition here to the rate of flow of charges here. So if I increase my resistance here, meaning I am reducing the rate of flow of charges. And you know what? Current is the rate of flow of charges. So if I'm increasing resistance here, I am also uh, reducing the rate of flow of charges here. And consequently, it will affect the current because current is the rate of flow of charges. If I reduce the resistance here, you can see my value is moving down. If I reduce the resistance here, then I am having few opposition here, and therefore a lot of current is flowing through that. And you can see the letter I here is becoming bigger and bigger, telling you that more current is flowing because I have reduced the opposition to the rate of flow of charges. So you can be able to vary that and see what happens here. Is a good picture. You can be able to see what is happening so that you can be able to relate to even to check the other properties of a conductor. And this is important, a good illustration for us. Thank you so much for uh, taking your time to observe this. You can share this. It will be helpful to other teachers of science and also to students. And also it's important to click that button of subscribe. Thank you so much. See you in the next